All right, so for number 3, for the 9x cubed, I'm going to break that down to primes and rewrite it as 3 times 3 times x times x times x. So 9x cubed, and its prime factorization looks like this. For 18x squared, well, that's 9. So 9 is 3 times 3, like we just did in the last one. X squared is x times x, and then we have the x plus 4. So here's my factorization for this one. And now I go through and find my least common multiple. So they both have a 3, so bring that down. And actually, let me use a different color for this, for them coming together. Both have a 3, both have another 3. This one, when I wrote out this factorization, I forgot to put my 2. Because it's 18, I need 2 times 3 times 3. 3 times 3 was the 9, times 2 is the 18. So I need to bring that 2 down for my least common multiple. Then this one has an x, so does this one. Need another x for them both. And then this one has a third x, so I have to bring one more x down. And then I also need an x plus 4. So 3 times 3 is 9, times 2 is 18, x times x times x is x cubed, times x plus 4. This is my least common multiple for those two expressions. If I wanted to turn 9x cubed into this least common multiple, I'd have to multiply it by 2, so that 2 times 9 is 18, and an x plus 4. So if I take 2 times x plus 4 times 9x cubed, I would get my common denominator. And if I wanted to turn the 18x squared times x plus 4 into this common denominator, I already have the 18, I have the x plus 4, I just need the x squared to become an x cubed, so that one I would only have to multiply by x. Alright, number 4. So we've got 4 times x squared minus 3x minus 10. Well, you gotta factor that. It's gonna factor into x minus 5 times x plus 2. Remember, if you're not sure how to factor that, use a diamond in a box problem. So your product would have been negative 10x squared. Your sum was negative 3x. So you needed negative 5x and positive 2x, so that it multiplied to negative 10 but added to negative 3. And then when you use your generic rectangle, you can factor it out to x minus 5x plus 2. Same idea on the second one, you've got to factor that out. So break down the 8 into 4 times 2, or you could take it all the way to primes. I'm just stopping at 4 because I know the first one has a 4. And then x squared plus 4x plus 4, that's going to factor into x plus 2 times x plus 2. So now we look for what they have in common and bring that down first. So they both have a 4. So for our least common multiple, we definitely have 4. Then I need the 2, since this one was an 8. I bring down a 2. Then we see they both have x plus 2, so I bring down an x plus 2. But this one has 2x plus 2, so I need another one. And then this one has an x minus 5, so I bring down an x minus 5. And so that's your least common multiple, or if you simplify a bit, you could say 8 times x plus 2 quantity squared times x minus 5. So there's our least common multiple. For the first one, in order to turn this into that least common multiple, well, it has a 4, it needs an 8, so we'd have to multiply by 2. And then it only has one of the x plus 2, so you'd have to multiply by an x plus 2. But if you take that original statement times 2 times x plus 2, you'd end up with your least common multiple. For the second one, you already have the 8. you already have the 2x plus 2s, you're just missing the x plus 5. So that one you would just have to, or sorry, x minus 5. That one you would just have to multiply by x minus 5, and you'd get this least common multiple.